Okay, hello everyone. So this is a second asynchronous lecture video for Tuesday class. So this should be covered in the lab, but as I made the lab, I will make up the lab class next week. So I included this part as a part of the regular lecture. But anyway, because anyway you will need to watch this video and use this video for the instruction of the lab lecture or your next assignment. So I will cover very details of the chi-square application we learned last week of the calculation, and I will also consider and mention some on the key skills of the coding issues in your final paper, because you need to manipulate some of the variables. As you might remember, as you did in the recording, there are some other ways of the change in the variables and the change the scheme of the variables. So I will cover that step by step. Okay. All right. Not sure. Okay. So the chi-square. So as you learned, if you have two variables, if you have two categorical variables, the nominal and ordinal variables, you will need to use the chi-square. So this is the basic setting is not only whether there are independent or associated, as you can check in the null and alternative hypothesis. You can measure the strength of the relationship in chi-square analysis. So there are the three possible sets. So the nominal, so the combination between the nominal and nominal variable, you are using the chi-square lambda. So in the SPSS program, you will have the chi-square lambda as the option. And if you have two ordinal variables, so the categorical ordinal variables, you will be using the chi-square gamma option. So not like the Shepard and Tukey, based on the level of measurement, you are using different set of the set of the options. So the mixture of the nominal and ordinal variable and ordinal and nominal variable, you will need to use the lambda. Instead of lambda, you will need to use the gamma chi-square, but you cannot find any of the direction of the relationship. So that will be also a very key part of the analysis of the interpretation of the chi-square analysis. So there are two nominal variables. For example, the race is nominal variable because the white and African American and other races, we cannot find any order. And the marital status, also we cannot find any order. We cannot say that the married is better than single or separated or divorced. So these are the two variables, and we are using the chi-square as these are two categorical variables, and as those two are nominal variables, so we can use the chi-square lambda as an option. So setting up the step number one, the null hypothesis is race and marital status. The race is independent variable here. Marital status is a dependent variable, because we can assume that based on the race, there is a disproportionate on the rate of the marital status based on the race. So we would say race and marital status are independent, race and marital status are associated. They're really alternative hypothesis. The critical area, you can find that in the table I uploaded last week. The calculation is in the regular lecture. If you don't have SPSS program, you may need to calculate it by yourself. But as we are using the SPSS program, you don't need to do it because the program will show it. And step number 4 is the conclusion, and you will see the p-value or statistical significance. If the p-value or the statistical significance is below 0.05, you will reject the null, and you will find the statistically significant association between those two variables. Chi-square nominal and nominal, the lambda. You can go to descriptive statistics and the cross tabulation as you created some of the contingency table with the column percentages. So always the row is the dependent variable, the column is independent variable. So put the two variables very correctly with the location of the variables. Independent variable is race, and dependent variable is the marital. So their cell display, or you can click the column percentages as you did in the cross tabulation, and also in the cross tab, in the statistics option, the statistics option, you will need to click the lambda because there are two two nominal variables. So after doing that, you will find the chi-square test and the Pearson chi-square. The value is the chi-square statistic. You could find it in Excel file, or you could find it by using the Excel file. So 110 and degrees of freedom is 8. So based on this table, we can find that 8 and 0.05 is 15.507. So in the critical area, 15.57 is the critical area, and then 110 is bigger than 15.51 as the critical value or critical area. So we would say that we reject the null. There is statistically significant association between race and marital status. So that will be the full steps of the hypothesis testing by using SPSS program when you have two nominal variables. So again, the directional measures, the chi-square, lambda, and lambda. So when you have the direction, for example, to find to find the condition of the prerequisite conditions of the direction, it should have the order. For example, the association between race and the marital status, as there is no increasing or decreasing order, such as the bigger number is the bigger, and the lower number is lower, or the bigger number, the larger number is higher, or something. So as we don't have any of the directional measures or the order, we cannot find any direction. So in lambda, there is only positive value, as there is no order, no direction, or no directional relationship in lambda. So if I say there is something, there is some direction in lambda, that will not be true. So also the lambda and the value of the lambda, symmetric lambda value is 0.031, 0.039, weak relationship based on this table. You will need to use this table as a standard whenever you measure the strength of the relationship. The lambda value, if we set the marital status as dependent variable, marital status dependent variable value 0.095. So here, when you use the marital status as dependent variable, as we could see in the here. So marital status is a dependent variable in the row, because based on, in our assumption in here in this example, based on the race, there would be very different proportion of the marital status. Some race would have the more married persons, but some race may have the lower chance of the marriages, or lower duration of the marriages because of the discrimination, or because of the other social standings. So when you use the marital status as dependent variable, very, very importantly, the lambda value is 0.05. So race of the respondent dependent, the lambda value is 0.00. So there is no relationship. So the interpretation is that when you multiply 100 and the lambda value, you can find a 5.9, which means 5.9% of the variation of the marital status can be explained by the independent variable in the race. So that will be the weak relationship, and then we are not able to have very strong confidence or very strong prediction power, even though we know about the independent variable or the race. Okay. So mixture of two variables, ordinal and nominal variable, because the degree is ordinal variable. Higher number or the higher degree would mean the better education. The marital status as well, and the nominal variable. The background is disproportionate distribution of the degree level by race. No, sorry about that. Oh, no. Sorry about that. Degree level by race, not the race. Distribution of the marital status by education level, by degree level. Sorry about that. So there is no association between degree and the marital status. Alternatively, alternative hypothesis, there is association between degree and marital status. Set up the critical area region, find the chi-square statistics in the SPSS program, and conclusion. So marital, again, the cross tabulation, the marital is dependent variable. Now degree is your independent variable because we assumed that based on their education level, we can find a different proportion of the marital status. The chi-square instead of the lambda, because we are using ordinal variable, we are using gamma. So again, the degrees of freedom is 16. We can use find the 16 here, 0.05, 26.296, which means 26.3 is the critical area or critical region. So 75 is bigger than the critical area here, around here. So we would reject the null hypothesis, saying that there is statistically significant association between degree and marital status. So there said that the ordinal variable and the gamma value is the negative value. But again, as the two variables are ordinal and nominal, so nominal variable cannot have any direction, positive direction or negative direction. We cannot find any direction. There is no direction in order in nominal variable. But there is a moderate association because the value, the absolute value is 0.159. So negatively or positively, the strength of the association is moderate because it belongs to this range. But as we are not considering the direction of the relationship, the sign of the lambda and the gamma value is not meaningful. So we can use the absolute value of the gamma when you measure the strength of the relationship. But when you measure or when you find the direction of the relationship, the sign of the gamma value will be very important. Ordinal and the gamma variable. So there will be the reverse coding issue. So one type of recode but change the direction of the attributes. This process is required when the variable has attributes meaning more positive, stronger, larger, which are assigned as larger numbers in the variable. So for example, the direction of the relationship, the value should be ordinal or metric variable. The positive relationship means both variables are independent variables and dependent variables change it in the same direction. So you might remember that I mentioned this one very shortly last week. So if they move together in same direction, there is positive relationship. Negative direction, it means that they are moving in opposite direction. Example of positive relationship is that if age goes up, if you grow older, if you get older, the height is usually and in general going higher when you are young. So there is, if age increases, the height also increases in young ages. The example of the negative relationship can be the social class. The higher social class, there would be the lower chance of having the higher number of the bad health days. If social class increases, then the number of bad health days decreases as they are moving in different direction or in opposite direction. There is a negative relationship. So in correlation, we will cover later, we just covered very shortly. There is positive correlation if they move together. Increases in x-axis, increases in the y-axis. There is negative direction here and no correlation. So the condition of health, the excellent, good, fair, and poor, and we would say that excellent is the better or the positive health condition. But the problem is the values are coded as 1. The best health condition is coded as the lowest number, excluding the missing value. So there is the problem. The problem is the high value in the number or high value in this variable is negative health condition. So when you interpret the gamma, you would say that there is positive relationship between the degree and the health condition. However, the positive relationship is actually the negative direction because the higher number would mean increase in health condition would mean the negative direction of the relationship. So this is so tricky. So if you need to set up the relationship at the directional measure, you need to align that the higher number should mean positive, larger, better, and anything the better meaning of the conceptualization. So now you can recode the variable into the new variable. Higher value should indicate the better health condition. So let's say that the old value, the one was coded as excellent, and that will be coded as 4 in the new direction. 2 is good, 2 in original variable will be 3, 3 in original variable as a fair will be 2, 4 in the poor will be 1. So as you learned in the recode process, and I will post on another video of the recode later, so you can change the name. The 1 will be, so based on this table, you can use this coding scheme to here. 1 is, the 1 in original variable will be 4, 2 will be 3, 3 will be 2, 4 will be 1, and continue. And you should not forget that the value labels, without the value labels, that will just show very simple table. So going to that, and 1 will be poor, right? The 1 will be poor in new variable, 2 will be fair, 3 will be good, 4 will be excellent. Then the original variable excellent is now in excellent for 359 cases here, so they are all matched together. Okay, so now we are ready. The degree of the health condition, so it was coded as RE health. Right here I named it RE health condition. So degree and RE health. The background is the disproportionate distribution of a health condition by their education level, the degree level. The null is there is no association between the degree and the health condition we recorded here. Alternative hypothesis said that there is some association between their education and health condition. Set the critical area, find the chi-square statistics, and the conclusion. The re-health is the dependent variable, the degree is independent variable, the gamma is the independent, gamma is the option, and then 12 is the degrees of freedom, 12 is here in the row, 0.05 is the p-value, and 21 is the chi-square statistic, chi-square critical area. So 114, which is clearly bigger than the chi-square, the critical region. So we can say that we reject the null hypothesis, and there is a statistically significant relationship between degree and health condition. So now, very importantly, there is the gamma. Now, finally, we can find the strength of the relationship here, and based on the sign of the gamma value, we would say that there is positive relationship, as the sign is a positive, and 0.326 belongs to the evidence of strong association. So we would say that there is strong positive association between the degree level and health condition, coded as the higher number is the better health condition. So respondents who have the higher degree level tend to have the better health condition. Alright, so religious liberalness and the re-health as well. The religious liberalness is that the 1 fundamentalist, and the 2 is moderate, and 3 is a liberal. So the higher number would mean, in this ordinal variable, higher number would mean more liberal religious belief. Because the religious belief and health condition, there might be some of the relationship, but we are not sure that would be statistically significantly associated, or they are independent from each other. So these are the expectation I skip here. The 6 is the degrees of freedom, as you can also check later. 6 and 0.05 p-value is 12.592 as the critical region. However, the chi-square, Pearson chi-square statistic is only 8 below 8, which means the below the statistical, the chi-square, the critical. It means that we fail to reject the null hypothesis, and then there is no association between religious liberalness and the health condition. And also there is the value that 0.182, gamma value is 0.182, but it's not meaningful because, okay, again, this is very important. Even though there is some relationship, in this gamma value, we already confirmed that, we already argued that there is no association. So when there is no association, measuring the strength of the association is not very meaningful. So that's why gamma value is 0.182, but we don't need to even measure the strength of the relationship because we already argued that there is no association. Alright, the dummy coding is as well. One type of recode but changing any type of variables. The dummy is the binary variable. So we will use this method for the independent variable, independent sample t-test, and now you will use the any independent variable you will need to put in regression. We will cover later. The reference category will be coded as 0. The target category will be coded as 1. So it's required for easy correct interpretation. In case you'd like to test the race impact to the incomes, for example, the original variable coded as 3 categories as the white and African American and other races. And you need to record the variable as a binary variable because you need to interpret that compared with the reference category. Reference category coded as 0 here. Some target category has some more and the less variable income. So I will just cover details in the actual class when I come back, and I will add more, but I'm just covering the conceptualization. The white, African American, and others. The coding scheme is 1 is white and 2 is African American, 3 is other races. So we will use the coding scheme as the African American is coded as 1, white and other races are coded as 0 as a reference group. So 1 original variable in white will be 0, 2 in original variable, the African American will be 1 as our target category, 3 original variable in original variable as other race will be 0, that will be the reference category in our new variable. So the black race and the dummy variable coded in regression, and 2 is 1, okay, here 2 is 1, and else everything else will be 0 because white and other that will be coded as 0. So 0 is other races, 1 is African American. But in this coding, black race is coded as 1 and all other races are coded as 0 as the reference category. So you can manipulate this categorization based on your needs, but in this time we are using African American as the target category. We will need to compare with the reference category. So after the changing the African American, here keep it the same, the number of cases, but other races are bigger than that. So the reverse coding is very important when you align the direction of the relationship, which means higher number in that variable must mean the higher or the better, the larger better, the better or something, the good meaning, so that we can have the better interpretation. Not always, but in most cases. Dummy coding is 0 and 1, and we'll cover more and more details of the application when I cover multiple regression and the regression in the lecture in next week, I think. Alright, so I will add some more videos about the demonstration of the SPSS program. Okay, so thank you very much for your attention and see you in next video.